What is a closed-loop control system? Imagine you're driving and you turn on cruise control. The car maintains the speed you chose, even on a hill. If the speed drops, the engine automatically accelerates. If it goes too high, it eases off. This is a perfect example of a closed-loop control system. In simple terms, a closed-loop system is one that uses feedback to adjust and correct its own operation. Unlike an open-loop system which simply executes an order without checking the result, a closed-loop system measures its output, compares it to the desired value, and makes constant corrections to stay on target. To help you understand it better, let's think about the key components. There's a reference point, which is the value you want to achieve, for example, 20 degrees Celsius. Then there's the process, which is the action itself, like turning on a heater. The sensor is what measures the output, like the thermometer that measures the actual temperature. The controller is the brain that compares the current temperature with your desired one, and if there's a difference, it sends a command to the actuator, which is the component that performs the action, like the heater. And all of this happens in a constant cycle known as the feedback loop. Your home's thermostat is the perfect example. You tell it you want 22 degrees and the sensor measures that it's 18. The controller tells the heater to turn on. As the temperature rises, the sensor continues measuring and sending that information back to the controller in a continuous loop. When it reaches 22 degrees, the controller turns the heater off. In short, closed-loop systems are the foundation of most modern technology that requires precision and stability. From robotics and drones to industrial systems and autonomous vehicles, their ability to correct themselves makes them immensely valuable.